Can you solve this problem without a calculator? First, we know x is an integer. So let's write here all we know about x. Second, we know it's not negative, because a negative number to the power of 3, for instance, so a is positive and negative of a is obviously a negative number. I'm writing this way just to emphasize that this is indeed a negative number. So a negative number to the power of an odd number, for instance 3, this is negative of a times negative of a times negative of a, and this is of course the negative of a to the power of 3. This is a positive number, but with this negative sign, this results into a negative number. Since this is a positive number, x must be positive as well. We also know that x is not 0 or 1, because 1 to the power of 23 is 1. So we have a lower limit for x. It is greater than 1. What about the upper limit? Let's have an idea about the range of possible values of x, observing how many digits this huge number has. It has 20 digits. 3, 6, 9, 12, 15, 18, 20. And 10 to the power of 23 has 24 digits. For instance, 10 to the power of 3, it's 1,000, has 4 digits. So 10 to the power of 23 has 24 digits. As a consequence, we know that x must be less than 10. So the range of possible values is greater than 1 and less than 10. But we also know that x must be odd, because an even number to the power of 2, 3, to the power of 23 is an even number as well, of course. So the possible values for x are 3, 5, 7, and 9. We eliminate all the even numbers between 1 and 10. Okay, so now let's pay attention to the last digit of the number, which is 3. If x is 5, we would obtain 5 squared is 25. The last digit is 5. 5 to the power of 3 is 125. Again, the last digit is 5. And so on. 5 to 23 will be a number with the last digit is 5. So we can eliminate 5 as well. The possible values for x are 3, 7, and 9. For the same reason, we can eliminate 9. Since 9 squared is 81, the last digit is 1. The next term, 9 to the power of 3, has a 9 as a last digit, and so on. It will repeat a sequence of 1, 9, 1, 9. So there is no possibility of having 3 as the last digit of a sequence for x being equal to 9. Okay, so the only possible solutions are 3 and 7. If it is 3, let's write here the power and the last digit of that number. If the power is 1, of course, the last digit is 3. If the power is 2, 3 squared is 9, so the last digit is 9. 3 to the power of 3 is 27, so the last digit is 7, and so on. The next one will be 1, because 7 times 3 will be 21, the last digit is 1, and the next one is 3 again. So it is possible that 3 is the value for x, because the last digit sometimes is 3. If we pay attention to this sequence, it is a periodic sequence. Every 4 values, it becomes 3 again. So the next one to be 3 will be the power 9, the position 9 of the sequence. The next one, it will be 13. The next one, 17, 21, and 25. So the position 23 of this sequence has a last digit which is different from 3. And so we can eliminate 3 from the possible values for x. And we conclude that the solution is 7. But before verifying if 7 is indeed the solution, let me tell you that there is another way to verify if 3 is the solution or not, by testing if this number, this huge number, is multiple of 3 or not. Do you know how to do it? So now let's verify if 7 is the solution. Again, the same method. 7 to the power of 1 is 7, so the last digit is 7. 7 to the power of 2 is 49, so the last digit is 9. The next one will be 9 times 7 is 63, so the last digit is 3. The next one, 7 to the power of 4, the last digit will be 1 because 7 times 3 is 21. The next one will be 7, obviously, and so on. 7 to the power of 6 will result in the last digit will be 9. And the next one will be 3. And you can see that it is a periodic sequence as well. 7, 9, 3, 1, 7, 9, 3, 1. So every 4 terms you have the number 3 again. So if you obtain 3 on the position 7 of this sequence, the next one will be the position 11, 15, 19, and then 23. In this sequence, the position 23 has a last digit equals to 3, verifying that 7 is indeed the correct answer.